Have you ever taken a couple of simple, innocent numbers like this one here and this one here, divided one by the other, and ended up producing a monstrous, messy number like this? Or this? Or this? And thought to yourself, what on earth have I done? If you have, you are not alone. And no, you have not done anything wrong. These strange numbers aren't monsters. They are repeating decimals, and as messy and strange as they seem, they're actually, well, interesting. And even, dare I say, magical. One thing that you need to know about repeating decimals is that you'll never see the true end of them. If your screen were infinitely long, they would fill every part of it. A string of numbers this long must be an enormous number, right? Well, not really, to be honest. Sure, there are a lot of digits there, but in fact, this is really just this. What do we know about 1/3? It's only a fraction of something, a part, a portion, not even one whole thing. So why so many repeating threes? Good question. Let's take a look. Let's say we had one whole dollar and we were told to take 1/3 of the dollar. We can't do this, so instead we divide by 3 like this. We end up with 33 cents, which should make sense, but behold, 1 cent is left over. Most humans can handle that. Just take the 33 cents and walk away. But calculators, oh no. They try in earnest to divide that remaining 1 cent. It takes that cent and, just like the dollar, it divides it by 3 and ends up with 3 groups of 3 little bits and 1 little bit left over again. So, it repeats its efforts, each time dividing the tiny little remainder into 3 groups, only to always have 1 left over. Try as it might, it can never get rid of that pesky remainder of 1, although it is getting smaller and smaller and smaller and smaller, infinitely small. I like to imagine a repeating decimal being kind of like the tail of a comet. On this side of the decimal, the whole number, the main part of the comet. This side? This is the misty, dusty tail. Now, Comet Tails are not infinitely long, but like repeating decimals, they're simply bits and pieces that are getting smaller and smaller and smaller as they get farther from the comet itself. You might, in fact, see the tail as the most beautiful, magical part of the whole comet. When you see a repeating decimal, you are seeing something that is magical too. Something that, if you let it, touches infinity. Now, we humans struggle with infinity. We are efficient. We like to shorten that tail for 2 reasons. 1, easier to read. 2, easier to write. The way we shorten the repeating tail, while letting others know that we have indeed just spotted a magical little piece of infinity, is to do this. That little line allows the reader to know the part that repeats. It might look like this, or this. Imagine tails that are different colors and patterns. Maybe a tail with all 3s is pure green. But a tail with repeating sets of digits like this is a rainbow of patterned colors. Another way to shorten a repeating tail is to do something like this. A calculator may round the last number up, like so. Whatever the method, stop and appreciate what you are witnessing. A piece of infinity is trying to reach out to you through a calculator screen or the pages of a notebook. So, can any number end up with a repeating decimal tail? Do they occur only when you divide numerators by denominators? Excellent questions, and ones that I will leave you to explore. I recommend that you explore various kinds of fractions, both proper and improper. Is there a way to guarantee you will find one? And what colors might they be? Are there lots of them out there? Good luck, everyone, and happy exploring.